Hey kids, it's very good to see you. Are you excited for another adventure today? Come on, brilliant kids, let's start our journey. Did you know that math and science are all around us? Yes, that's right. But today, we're only focused on our movements, practical motions, and daily phenomenon. Do you know Isaac Newton? This is him. He studied and discovered the laws of motion. There are three, but we're only focusing on one. And that's the law of action and reaction. It sounds big, right? The law of interaction explains that for every action, there's an equal and opposite reaction. If object A exerts a force on object B also exerts an equal and opposite force on object A. In other words, forces results from interaction. But in this journey, we'll make it simple. But how simple? Did you know that walking, biking, and even a bird flying on the street can represent the law of interaction? Come on, let's not wait any longer. Let's dig in.
To show you an example, Rama is walking in a hallway. This explains that when we walk, we exert a force that pushes us backward, and friction responds by exerting a force that pushes us forward in the other direction. In essence, we couldn't walk if there was no friction.
Let's have another example. Corey and Willie are playing basketball. These two boys are bouncing the ball within the ground. Did you know that the ball is able to bounce because of the reaction from the ground? How cool is that? If we were to ask Isaac Newton, he would tell us if there was no reaction, then the ball would not bounce back, but rather it would stick to the ground. To further explain, when a basketball is dribbled, it will hit the ground with a force. The force that the ball reaches towards the ground is paired with the force that the ground reaches toward the ball. The second force acts in the opposite direction, causing the ball to race.
Now what if we ask Isaac Newton about skateboarding? He would tell us that the reaction is equal in strength to the action, but acts in the opposite direction. When skateboarding, an action occurs when the skater pushes against the ground with their foot. The ground then pushes back against the skater's foot, which creates an equal and opposite reaction. This is the force that starts moving the skateboard forward. Isn't that cool?
Have you ever seen your dad hammering? Isaac Newton would like to say something about that. When there is something we need to repair in our home, we use a hammer. When a hammer hits a nail, it drives the nail downwards into the piece of wood. The reaction is the force of the nail pushing upwards on the hammer, which stops the hammer. That's why the hammer stops at exactly where the impact occurred. Because there is a net force acting on the nail, it is driven down the wood. Always keep safe using a hammer, okay?
Now let's see something interesting. A group of Olympic girls rowing a boat. When they start rowing, they push the water backwards using the oars. The force applied by the oars is called the action force. The water gives a reaction force to the oar because it applies an equal and opposite push on the boat, which causes the boat to move forward. Row, 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 row! Yay! Gold for the Philippines!
Telma and Nana are good friends. They love playing baseball. When playing baseball, a player would hit a ball with a baseball bat. Consider the interaction between the baseball bat and the baseball. The baseball forces the bat to the left. The bat forces the ball to the right. Together, these two forces exerted upon two different objects form the action-reaction force pair. The force exerted by the bat hitting the ball will be equal in magnitude but opposite in direction of the force the ball exerts on the bat.
Have you ever wondered how birds fly? Of course, birds flies using its wings. The wings of the bird acts as the action force as it pushes air downwards. In turn, the air reacts by pushing the bird upwards. As it flaps, its wings push in a downward and a backward direction. This pushes air downward and backward.
Did you enjoy our adventure today? To sum it all up, the law of action-reaction states that for every action, there is an equal and opposite reaction. Two objects apply the same force on each other no matter how more massive or small one object is in relation to the other object. This also applies even when objects do not move. Examples of Newton's third law of motion are ubiquitous in everyday life. Learning the laws of motion are essential because they relate to everything we do or see daily. These laws tell us how things move or stay still, and why we don't float out of our bed or fall through the floor of our house. We hope you've learned a lot today.
Gusto niyo pa ba ng mga video na nakakataba ng utak? Ano po ang hinihintay nyo? Subscribe na!